Hi dear friends, in this report you're going to find the solution of consolidation homework. Let's start with determination of coefficient of consolidation CV by log time method. There are two different methods to evaluate the coefficient of consolidation. One of them is log time, the other one is root time method. We will use time readings and dial gauge readings obtained from consolidation tests in laboratory, and log time takes its names from the x-axis. This axis is log scale, and we construct this graph using these dial gauge readings. Be careful about the x-axis; they must be in terms of minutes, and y-axis is dial readings. We construct this graph, but we should make a correction at the beginning of this graph. That's why we should define a D0 value for the dial readings. And to identify this value, we use two different time readings. The first one is dt, and the other must be 4 times of t. I mean, this is dt, this is d4t, and dt is here. We read from here, it's the 15 seconds, and the other one is 1 minute. It is 4 times 15 seconds, and 60 seconds, I mean. These are the dial readings related with these times, and here the difference between these dial readings. And according to the assumption, here are the drawings. This is D1, this is T1, and this D2 is corresponds from the 4D for T1 to 4 times. Here the time is 4 times the first one, and this is the D1 and D2 difference between these. And as you see from here, the difference will be same. Here the difference will be same with the D0 and D1. According to this assumption, we make some calculations here, and the aim of this procedure is to identify the T50 value to evaluate the coefficients. Now we identify the D0 value. Here the D0 value we subtract from the first one here, and we draw two lines. Here the primary consolidation line, this is the secondary compression line. These lines must be best straight lines, including these points. So we draw and make an intersection here. The intersection point of these two lines called T100. It means the consolidation ends at this point. 100% of consolidation corresponds to T100 and D100. From these values, as you see here, we calculate the dial readings for T50. Here the dial readings, and here the time for T50. In the experiments, there's double drainage. It means at the bottom, and the drainage takes place at the bottom and the top of the specimen. So the drainage path is the half of the thickness of the soil sample, and the time factor for T50 can be calculated like that. Here the 0.5 means T50. 50% of the consolidation takes place at that time. We will see this formulation later again. From here, we calculate here the time factor and the coefficient of consolidation by using these time factors and the time read from here. As you see, this is 1, 2, 3, 4. T50 is 4 minutes. We should convert them into year. This is the conversion factor for 4 minutes. Here is the coefficient of consolidation. There's another way, as I said, it's the root time method. It takes the name from here. We will use the square root of the time readings. Here is the time readings, and we will use the square root of these time readings in this axis. Again, we draw a straight line, base straight line from the initial point of this parabolic graph. We call this point, as you see, the cross-section point. Here is a square root of time factor, and we read the number from here, and 1.15 times of this time factor is another point recorded here, and we draw another line from this point to which passes through these points. As you see, this is the second point we defined, and the intersection point is called square root of time for the consolidation. For 90% consolidation, this subnumbers explains the amount of the consolidation. Here are the required readings, required calculations. We define these numbers from here, and we can read them here. And again, using the same formula, we can calculate the coefficient of consolidation here. And the other parameters are compression and recompression indexes. Again, we can evaluate these parameters from a consolidation test. As you see, these are the time load intervals, and these are the void ratio values depending on these load intervals. Again, we plot this graph using these values. Here is the logarithmic scale. This axis is logarithmic scale, and we plot these values onto this graph. Again, we draw two best straight lines from here and from here. As you see, the intersection point is called pre-consolidation pressure. Pre-consolidation pressure is the maximum effective overburden stress that the soil has sustained in the past. Keep this in your mind. And by calculating the slope of these lines, we can evaluate the CR and CC values. Up to this point, we learn how to use the consolidation test results, how we will find the required parameters. Now we will see the application of these parameters, these coefficients. In this question, there's a clay layer for meter thickness, and there are sand layers, upper and lower portions. This means there will be drainage both at the top and the bottom of the clay layer, and here there are the coefficients that we can use for the calculations, and we will calculate the consolidation settlement at the midpoint of the clay layer, and the initial effective stress is here is written, and the stress increment at this point is given here. And here are the formulations that we will need for the calculation of consolidation settlements. We start with the calculation of initial stress and the stress change, and we will calculate the final stresses at the midpoint of the clay layer. and then we will use this formulation to calculate the consolidation settlements. Here are the thickness of the clay layer, because consolidation takes place in clay layer, so we will use the height of this layer. And if you use this in terms of centimeter, the results will be in centimeter. So we can calculate by using this formula the consolidation settlement. In the second part, we are going to calculate the consolidation settlements after 6 months of the embankment. It means 0.5 year. And here, start with the definition of calculation of drainage path. As you see here, double drainage. So we will use the half of this layer as the drainage path. Here is the drainage path. And required time factor is here. We can calculate by using this formula. This is already given, and T is that we are not using 6 months, we are using in terms of years. Please be careful about this. And we calculate the time factor as 0.1. Then there are two different formulations to evaluate, as you see here, to evaluate the degree of consolidation. For the situation, the degree of consolidation is more than 60%, we will use this formulation. And for the situations that the degree of consolidation is less or equal to the 60%, we will use this formulation. And so go on with the simple one. We will try this one if and we will calculate the degree of consolidation. If the result is more than 60%, this means we should use the other formulation. Now, the result is compatible with the assumption, so we can use this one. This is the degree of consolidation. The amount of settlement at any time of the consolidation is equal to total consolidation settlements times degree of consolidation. Here the settlement amount after 6 months of the embankment. Again, the same type of question. We will calculate the consolidation settlements after 3 years. Here the time factor for 3 years. It's given as years, so we can use it directly. And drainage path is 2. We calculate the time factor. Now, let's try the simple one. We don't know which formula is suitable for our situation because we don't know the degree of consolidation. Let's start with the simple one. We try to find the degree of consolidation, the capital U, and it's more than 60%. So we should use the other formulation. And here is the other formulation. We use this formulation, and we find the degree of consolidation, and it's more than 60 here. The degree of consolidation, it's more than 60%. So we use the correct formulation. Again, the same thing, and here the amount of the settlements is at time t. We can calculate amount of settlement by multiplying the total settlement with the degree of consolidation. And here is the results. And in this part, we're going to calculate the required time For the half of the consolidation settlement take place, it means that we know the degree of consolidation. It is U is the 50%, half of the consolidation means 50% of the consolidation. We know the U value, so we can calculate the time factor for this consolidation amount. And here is the another formula that we can evaluate the time required for this amount of consolidation. And when we write the values in this formula, we can calculate the required time as 1 year. In this question, there's a 6-meter deep layer of sand here and a clay layer. At the bottom, a sandy gravel layer, which means the drainage can take place from bottom and from top. In this question, a 3-meter thick layer of fill is to be placed rapidly on the surface over an extensive area, and there's a loading here. Here are the required parameters and the required formulations. There are 2 different formulations to calculate the consolidation settlements. One of them is here, one of them is here. And as you know, we start the calculation of the consolidation settlement with the calculation of the stresses. This is the initial stress, initial effective stress at the midpoint of the clay layer, as you see here. And this is the final stress. How we calculate this? This is the amount of fill placed onto this soil profile. Stress change is 60 kilopascal. As you see in this formula, we are going to use this formulation, and we will use the stress change. And this is the coefficient of volume compressibility. Here, the settlements in terms of millimeter. And here, another question. What is the degree of consolidation U at the center of clay layer when the pore water pressure at that depth is equal to this, and what's the effective stress at that depth at that time? Again, the initial pore water pressure at the midpoint of the clay layer is here 80 kilopascal. How we calculate it? Here is the groundwater table. At the midpoints of the clay layer, 2 meter plus 6 meter, it is 8 meter. 8 meter times unit weight of the water, it is 80 kilopascal, and total pore water pressure at the midpoint of the clay layer. Here, the small u is used to express the pore water pressure. This is the initial pore water pressure. This is the excess pore water pressure. Excess pore water pressure means the stress increment due to the loading. As you remember from the lessons in the clay type soils, if you apply a rapid loading, it will cause a pore water pressure generation inside the soil particles. Here is the excess pore water pressure. It's caused by the loading. This is the initial pore water pressure, and this is the excess pore water pressure. We don't know the excess pore water pressure, but we know the final total stress. It is given here. So we can find the excess pore water pressure here. Initial excess pore water pressure at the midpoint of the clay layer will be 60 kilopascal because it's generated due to the loading, and there are 3-meter thick fill layer. This is the amount of the loading, and there's a direct proportion between the excess pore water pressure and degree of consolidation. So we can write here, as you see, and this is the degree of consolidation for this situation. Again, the time is asked here for the 50% of the degree of consolidation. It means the capital U is 50, and we can calculate the time factor using this formulation, and we can calculate the drainage path here, and coefficient of consolidation is given in the question. So we can calculate the time from this formulation required for this amount of consolidation. Now we're going to calculate the amount of the settlement at the end of 20 months. Here the conversion, we should, in this formulation, we use this T in terms of years. So please be careful about the conversion of the times. Here is the months, here is the conversion for the year. This time factor is evaluated as 1. And again, we will try which formulation is suitable for us. Let's start with this one. And this time factor is evaluated as 94. And now, again, we're going to calculate the amount of consolidation settlement at any time. It's equal to total consolidation settlement times degree of consolidation. Here is the amount of the settlement at the end of 20 months. In this part, the amount of settlement is given, but the ask is the time required for this settlement. Here, as you see here, this is the maximum consolidation settlements. I mean, this is the amount of the settlement at the end of the consolidation. It means 100% of the consolidation is completed. Again, we can calculate the degree of consolidation by using direct proportion. For this amount of settlement, how much degree of consolidation is required? We can divide them into each other, and we can find the degree of consolidation, and this is less than 60%, so we can use this time factor formula and calculate the time factor required for 40 millimeter settlement. And from this formulation, we can calculate the required time, this is 0.1 year, for 40 millimeter settlement. Here again, there's a clay layer, there's a sand over it, and be careful about this. There's an impermeable bedrock here. When you are calculating the drainage path, we are going to use whole thickness of the clay layer because there's no drainage from this part. There's only one-way drainage. It's from the top of the soil. In this question, 3-meter depth of fill is placed rapidly. This is important in short time, rapidly. It's important for the clay soils, and the required parameters are obtained from laboratory tests and given here. As you remember at the beginning of the record, CR, the compression index, and the compression index are here, and this is the pre-consolidation pressure. It's given here, as you generally do to calculate the consolidation settlements. Initially, we find the stresses. This is the initial stress, initial effective stress at the midpoint of the clay layer. And this is the final stress. Here is the loading. This is the final effective stress at the midpoint of the clay layer. By using this formula, before this formula, how we understand to use CR and CC both. In this graph, we plot and write our stress levels. One of them is here, one of them is here. So for this part, we will use these coefficients, and for this part, we will use these coefficients. For the consolidation settlement problems, you have to draw these graphs. You have to see the level of stresses, if they are bigger or smaller than the pre-consolidation pressure. So we see that we will use both of these coefficients, and so we will use this formulation. This is the height of the clay layer. Please be careful about this. Don't confuse. You will write the height of the compressible layer. It means you are going to write the height of the clay layer. It is given the initial pore water, not pore water, initial void ratio here, and these are the coefficients, and these are the this is the pre-consolidation pressure, and this is the initial effective stress, and this is the final effective stress, and again this is the pre-consolidation pressure. So we use this height as meters, so we find the result as meters. Here, what's the pore water pressure at the midpoint of the clay layer? As you know, the pore water pressure is changing during the consolidation, and we can calculate the degree of consolidation by using the pore water pressure changes. Here is what the pore water pressure at the midpoint of the clay layer when the degree of consolidation is 50% at that level. 50% means half of consolidation is completed. This is the initial pore water pressure. How we calculate is, here is the groundwater level. At the midpoint of the clay layer, there are 2 meters above this point. 2 meters is multiplied by the unit weight of the water. Here, it's 20 kilopascal. The excess pore water pressure is due to the loading and will be dissipated when the consolidation ends. It's caused by the loading. It is 60 kilopascal, and at any time during the consolidation, the excess pore water pressure is measured as 30 kilopascal, which is for 50% of consolidation. So the total pore water pressure for this situation is, this is the initial one, this is the excess pore water pressure at any time during the consolidation, and this is the final pore water pressure at the midpoint of the clay layer for 50% degree of consolidation. Now we're going to calculate the time when the effective stress increased by 48 kilopascal at the midpoint, mid-depth of the layer. We are going to make our calculations according to the midpoint of the clay layer if it's not specifically defined for any point. Here is an importance equation. Please be careful about this equation. In fine grain soils, in cohesive soils, change in effective stress is equal to change in pore water pressure, excess pore water pressure. Here is the excess pore water pressure at the beginning of the consolidation, and this is the change in effective stress. As I said previously, we can calculate the degree of consolidation by using the change in effective stress. Here is the calculation for degree of consolidation. If 100% of the consolidation takes place, 60 kilopascal pore water pressure will be dissipated. For what situation 46 kilopascal excess pore water pressure will be dissipated? This is the question. So we can calculate from here. It is 80% of the consolidation, and this U is bigger than 60%. So we can use this formula, and time factor for this degree of consolidation is calculated here. From here, we can calculate the required time for this effective stress increase for this situation. It is here, it's written here. This is the required time for the effective stress to increase by 48 kilopascal. Again, we will use the same idea, same approach. Please be careful about this. Again, in this question, there's a loading and there's impervious rock. Be careful about this. No drainage from the bottom of the soil layer. The drainage on the top of the clay layer. I made some calculations here, but the result is independent from these calculations. Because in the question, what will be the increase in the effective stress at point A, it is the midpoint, when the excess pore water pressure has decreased by 17 kilopascal. According to this equation, you can see we can directly understand that the amount of decrement is equal to the amount of increment in the effective stress. I mean, we can directly say the increase in the effective stress is equal to 17 kilopascal. Please be careful about this. And the second part is, what is the average degree of consolidation in the clay layer when it has settled by 6 millimeters? In the question, it is given, it is 24 millimeter consolidation settlements will be evaluated at the end of the consolidation. This is 100 consolidation, and again, we can make our calculations proportionally. The degree of consolidation will be 25. Here is the time is asked for half of the consolidation, and the relevant time factor is already given here, but we can calculate by using the formula. And again, from here, we can calculate the required time. As you see here, the drainage path is given as 3 meters. As I said, this is impervious. The drainage path is here. This is a drainage path. So we will use as 3 meters. Please be careful about this. So we calculate the required time for the completion of the half of the consolidation. And this is the last part. What is the degree of consolidation at point A? When the excess pore water pressure at this point has decreased to 16 kilopascal. Initial excess pore water pressure is given here. It's the excess pore water pressure recorded at the beginning of the consolidation. When the consolidation ends, this amount of pore water pressure will be dissipated. But at any time, some of the excess pore water pressure dissipated, and final value is recorded as 16 kilopascal. 24 kilopascal is dissipated. We can calculate the degree of consolidation by using the amount of dissipated pore water pressure. Here is the proportional calculation, and we can calculate the U value by using decrements of the excess pore water pressure. This is the end of the record. Take care of yourself. I hope you can understand the basic idea for the consolidation.